So on April 6th, the cloud was literally hit by a ballistic missile.
Yeah, which is just, it's wild to say out loud.
Right. Because, we call artificial intelligence the cloud, and it makes it feel so ethereal, like it's just this invisible thing floating above us.
Completely detached from the messy physical world.
Exactly. But the reality is the smartest AI models on Earth, they don't live in the sky. They are made of, physical cables, massive cooling towers, and just acres of concrete data centers.
Yeah, the brain might be digital, but the body is entirely physical.
And today, we are looking at what happens when that physical hardware is sitting squarely inside an active conflict zone, which is really our mission for today's deep dive.
Right.
We are shifting the lens completely away from market valuations and stock prices and, the endless boardroom drama over OpenAI's valuation.
Thank goodness.
Yeah, right? Instead, we're shining a massive spotlight on the physical infrastructure war of AI. We've got a stack of sources today covering real missiles hitting data centers in the Gulf, new non-U.S. chip supply chains coming online, and these rumor mill specs for a colossal 10 trillion parameter model.
Which is just a staggering number. And, for anyone listening to this, whether you're a developer spinning up new code or a small business owner trying to automate your back office or really just someone trying to understand where the future is heading, you need to know how the tech industry is bulletproofing its infrastructure.
Yeah, totally.
Because this deep dive, it isn't about doom and gloom. It's about how builders are engineering this incredible resilience in real time, right when the physical map of the world gets intensely complicated.
Right. So let's lay out the factual context of what just happened. On April 6th, the United States and Israel carried out strikes on Iranian cities. And this resulted in over 25 deaths following a rescue mission of a U.S. F-15 weapons officer inside Iran. In retaliation, Iran launched ballistic missiles and drones at Gulf Arab states.
Right, which escalated things very quickly.
Yeah, they struck a Qatar energy tanker, and critically for our focus today, those strikes targeted data centers in Qatar, the UAE, and Bahrain.
I mean, the abstraction of the cloud literally shattered in real time. We're talking about physical munitions threatening the actual servers that process global data workloads.
Okay, let's unpack this because one of our sources points out a fascinating geographic bottleneck here.
The Strait of Hormuz thing?
Yeah, so for decades, the Strait of Hormuz has been famous because roughly 20% of global oil transit moves through there, right, putting it at constant risk. But now the Gulf region also hosts nearly 20% of the world's planned AI data center capacity.
Which is just a crazy overlap.
It is. The legacy energy economy and the future intelligence economy are bottled up in the exact same volatile geography.
What's fascinating here is really the sheer speed of the engineering reaction. Because, this was the first real-world kinetic test of AI's hardware fragility.
Yeah.
And within 90 minutes of the first reports of those missiles, network engineers in places like Fujairah, they were already executing these complex protocols to migrate digital infrastructure.
Wait, 90 minutes. 90 minutes to move the digital backbone of massive economies.
Yeah.
Help me understand the mechanics of that, because how do you physically move a live AI workload that's, currently generating answers for millions of people without the end user experiencing a huge crash?
So it relies on a combination of anycast routing and distributed compute architecture. Basically, under normal circumstances, when you query an AI, the network routes your request to the geographically closest data center.
Just to reduce latency, right?
Exactly. But when those engineers got the alert, they manipulated the Border Gateway Protocol.
The BGP.
Right, the BGP, which is essentially the postal service of the internet. They updated the routing tables globally so that all incoming traffic was instantly diverted away from the Gulf servers.
Oh, wow.
And they sent it all through redundant underwater fiber optic cables to backup facilities in Europe and Asia.
But, they aren't just sending emails, they're moving active AI compute.
Which is the absolute hardest part. Shifting a static web page.
Yeah.
Easy. Shifting the active compute state of a massive neural network. That means syncing terabytes of memory across continents in milliseconds.
That's insane.
The fact that the system didn't shatter proves this fundamental law of infrastructure, which is that resilient systems aren't built during a crisis.
Right, they're built years in advance.
Exactly. By people who design power grids and data pipelines to fail gracefully.
Okay, but rerouting data away from a damaged data center assumes you have backup data centers built and ready to go. What happens when you can't even get the hardware you need to build those redundant centers in the first place? Because we've got this massive geopolitical tug of war happening over silicon right now.
Yeah, but physical constraints always force innovation, right? When access to a critical resource is restricted, the ecosystem kind of mutates and finds a new path.
And that new path isn't even happening in the West. According to our sources, it looks a lot like the Huawei 950PR inference chip.
Oh yeah, this is huge.
This chip is drawing massive enterprise AI orders right now,
Yeah.
specifically from tech giants like ByteDance and Alibaba.
Because inference is where the actual real-time queries happen. So
Yeah.
the silicon demands are just constant. And they're stockpiling the 950PR to run these workloads.
Right.
They're actively bypassing the dominant NVIDIA ecosystem, which, as we know, is subject to stringent U.S. export controls.
Right.
By adopting the 950PR, they're basically proving that high-level AI deployment can happen entirely outside the traditional U.S.-Taiwan supply chain.
Wait, I'm still stuck on this point, though, because if half the world is running on Huawei architecture and half the world is running on NVIDIA, doesn't that break cross-border software integration?
Yeah.
Aren't we essentially fracturing the global AI landscape into these regional isolated silos?
Yeah.
How is a fractured internet a good thing for the listener trying to access the best AI?
Okay, if we connect this to the bigger picture,
Yeah.
right? On the surface, yes, it looks like fragmentation, but consider the alternative. Up until very recently, there was a single point of failure in the global AI supply chain. If one specific manufacturing island went offline, or one company faced a critical shortage, the entire global progression of AI ground to a halt.
Oh, I see.
By developing the 950PR, these tech giants are creating robust, localized alternatives. It ensures that regional AI deployments don't rely on that single fragile thread.
So it's about decoupling the global risk,
Exactly.
building a parallel stack so a failure in one hemisphere doesn't crash the other.
That is the goal. And you see this momentum extending into the software layer, too. Look at the Chinese AI lab Zibu AI.
Oh, right, yeah.
Amid this wildly crowded week of global AI releases, on April 3rd, they shipped this speed-optimized proprietary model update. The sheer velocity of these localized releases proves that regional ecosystems are moving incredibly fast to build total self-sufficiency.
And the sources show this desperate need for resilience is also changing how developers build software on our end. Like, developer reports are now calling LLM API abstraction critical infrastructure.
Yeah, it has absolutely become a survival mechanism for software engineers.
For those who might not be building apps every day, an API abstraction layer means you don't hard-code your software to just one AI provider. Because, in March alone, there were over 30 major AI model releases or significant updates.
30.
In 1 month. Right. So if you're a developer, models are arriving, changing, or getting deprecated every 72 hours.
Which is an absolute nightmare if your entire business logic is tied to one specific model version.
Right.
If that model goes down because a data center got hit or gets caught in a crossfire, or if the provider just arbitrarily raises the price.
Your system crashes.
Exactly.
So I'm picturing an abstraction layer like a universal translator and an automatic backup generator combined.
Yeah.
Like if you're using a router tool like LidLM and provider A goes offline, your app automatically silently falls back to provider B.
Yep. The user never knows the difference.
And it routes based on performance too, right?
Right, yeah. Like if a new model drops that's 20% cheaper for the specific coding task your app needs, the abstraction layer just routes the query there dynamically.
Okay, but building all of this redundancy, the parallel hardware pipelines, the distributed data centers, the multi-model API routers, it takes an enormous amount of capital and effort.
Mm-hmm.
Why is it so urgently, existentially necessary right now?
Because the models themselves are scaling to a size where a single point of failure wouldn't just be an inconvenience, it would be catastrophic.
Which brings us to the Anthropic rumor that's just completely dominating the prediction markets right now, Claude Mythos 5.
The scale being discussed it's difficult to even comprehend.
Here's where it gets really interesting. Let me put it this way. A few years ago, a 70 billion parameter model was massive.
Oh, yeah.
Then we saw 400 billion, then 1.8 trillion. If a 70 billion parameter model is like the plumbing and electrical wiring for a skyscraper, Mythos 5, at an estimated 10 trillion parameters, is the infrastructure for an entire metropolitan grid. And according to startup analysis, prediction markets are giving it a 39% chance of shipping this month, specifically targeting advanced cybersecurity and complex code generation.
And we really shouldn't view Mythos 5 simply as a hype story about parameter counts.
Right.
It serves as the ultimate illustration of why the infrastructure redundancy we just discussed is mandatory.
Connect those dots for me. Why does a 10 trillion parameter model care if I have an API fallback router?
Okay, think about the core use case here. If you have an AI model tasked with live, active cybersecurity defense, monitoring network traffic for novel zero-day attacks and deploying countermeasures in milliseconds, latency is literally a matter of life and death for the network.
Okay, yeah.
If there's a split-second latency spike because a damaged undersea cable forced data to reroute across the globe, that isn't just an app buffering. It's a systemic failure of your defense grid. You need flawless, decentralized, redundant infrastructure to support a brain that large and that critical.
You literally cannot put a 10 trillion parameter brain inside a fragile body. But here's where my head goes. Can we even build enough power plants and lay enough concrete to support multiple 10 trillion parameter models running simultaneously?
Well, the industry knows this trajectory of compute is practically unsustainable without completely new mathematics. You can't just keep building bigger data centers indefinitely.
Right.
The physical footprint has to shrink.
Which explains the massive breakthrough from Google DeepMind that was highlighted in the research. DeepMind just introduced a new compression algorithm that cuts an AI model's memory requirements by a factor of 6.
A 6x reduction is a total paradigm shift.
But how do you shrink a model's memory by 6 times without lobotomizing it? Doesn't removing that much data make the AI noticeably dumber?
So it relies on two fascinating mechanisms, aggressive quantization and sparse routing.
Okay.
Quantization essentially reduces the precision of the numbers the AI uses to do its math. So instead of using highly detailed 16-bit numbers for every single calculation, DeepMind figured out how to use much lower resolution math in the areas where it doesn't actually affect the final answer.
Ooh, like rounding numbers when you're estimating a budget, instead of calculating down to the penny, because the broad stroke is really all you need.
That is a perfect analogy, and they combine that with sparse routing. A 10 trillion parameter model has an unfathomable amount of knowledge.
Right.
But when you ask it to write a Python script, it doesn't need to access the neural pathways that know how to translate ancient Greek.
Oh, that makes sense.
Sparse routing means the AI only wakes up the specific tiny fraction of the network needed for your prompt, leaving the rest of the massive brain dormant.
So by waking up less of the brain and doing simpler math, you dramatically lower the physical inference costs.
Yeah. And more importantly, you make it possible to run these highly advanced models on smaller, cheaper, and vastly more distributed hardware. It's the ultimate counter-movement to the giant data center, pushing the compute closer to the edge, closer to the user.
I mean, there's an incredible irony here. We're talking about geopolitical missile strikes, multi-billion-dollar concrete data centers, and models so massive they need new math just to avoid melting the power grid.
Yeah.
But while governments and tech titans fight this macro infrastructure war, the tools actually trickling down to everyday users require almost zero infrastructure on their end.
The practical layer of AI is operating in complete contrast to the macro chaos. It is just utterly unstoppable right now.
So what does this all mean? I saw a flood of SME tools released this week that illustrate this perfectly.
Yeah, let's look at what's actually landing in the hands of users.
First up, AWS just launched autonomous agents specifically designed for small to medium enterprises. We aren't talking about giant corporate deployments that take 6 months to integrate. These are designed to automate mundane back-office workflows for startups with minimal human oversight, though, keeping a human in the loop for critical tasks is highly recommended.
Right, it's enterprise-grade automation trickling down to the 5-person business.
Yeah.
The startup doesn't need to know how the AWS servers are routed. They just get the efficiency.
Exactly. And for the developers listening, I was reading the release notes for a tool called DomScribe. There's massive buzz around it right now.
Oh, yeah.
It's a completely free open source tool.
Yeah.
But help me understand what makes it different from the standard AI coding assistants we already have.
So it solves one of the most agonizing friction points in web development. Usually an AI coding agent can read the text of your code, but it's effectively blind to what the rendered application actually looks like on the screen. DomScribe interacts directly with the DOM.
The document object model.
Yes. The DOM is essentially the structural map of a web page. By connecting to the DOM, DomScribe gives the AI live visual context of the user interface.
Oh, wow.
So the agent can physically see the app it's building. It completely eliminates that endless, frustrating back and forth where you have to tell the AI, no, the CSS is wrong, the button is misaligned, move it left.
Right.
It connects the abstract code to the physical visual layout.
And for engineers dealing with computer vision data, the same automation of tedious tasks is happening. There's a new tool called T-Rex label.
If you've ever had to train a vision model to recognize specific objects, you know you have to manually draw bounding boxes on thousands of raw images. It's agonizing, manual work. T-Rex automates this.
Yeah, it's incredible.
You point it at your raw dataset, it automatically proposes the bounding boxes and labels based on zero-shot learning, and you just confirm or correct them. It speeds up data labeling by 10x. And then there's Criteo Go, which is bringing generative AI ad optimization directly to smaller startups, lowering the barrier to entry there too.
This raises an important question, though, because this contrast is something we really need to sit with.
Okay.
On one hand, we have nations literally fighting over physical infrastructure corridors, tech giants pouring billions into concrete cooling towers, and labs racing toward the 10 trillion parameter mark.
The clash of titans happening entirely out of sight.
Right. But the real revolution, the actual shift in human productivity, is happening quietly at the edge. A solo entrepreneur, a small ceramic studio, or a 3-person coding team can now spin up back-office operations and execute complex visual code workflows that would have required a 50-person agency just 12 months ago.
It's democratized scale.
Exactly. The massive geopolitical infrastructure war we started this deep dive discussing exists purely to make these small everyday miracles reliable and cheap for you. The unimaginable complexity at the bottom of the stack is absorbing all the geopolitical and technical shock so that the top of the stack feels effortless.
It's an incredible paradox to wrap our heads around. I mean, the physical fragility of the AI ecosystem was fiercely tested this week in the Gulf, but the immediate 90-minute routing response from engineers proved that this is an industry rapidly building armor. We're seeing resilience taking shape at every level, from alternative hardware pipelines like the Huawei chips bypassing single points of failure to software safety nets like multi-model API abstractions.
Right.
And all of this heavy lifting is happening to support the colossal weight of future 10 trillion parameter models, while simultaneously figuring out how to compress them and continuing to deliver incredibly powerful, highly practical agents to everyday businesses without a single hiccup.
We are entering an era where utilizing artificial intelligence is becoming delightfully simple and almost invisible for the end user. It'll soon feel like turning on a faucet. The water just flows.
Right.
But beneath the surface, the physical infrastructure required to keep that water flowing is rapidly becoming the most complex, guarded, and fiercely contested resource on the planet. And as these AI models get smarter, and as the tools you use get more beautifully abstracted, you have to wonder, in the decades to come, will the ultimate winners of the AI race be the people who write the best code, or the people who pour the most resilient concrete?